Thank you. So good afternoon. My name is José Maria Gómez. I'm going to present the topic Smallsats, a new opportunity for research. So probably you have seen some pictures of these. These are missions that we have been participating inside the ICCUB. These are just three. There are many others. Okay. One is Gaia, probably the jewel of the crown in this case. Then we have Solar Orbiter that is now, nearby the Sun and starting its operational phase. And here we have Ariel, which is a new mission that is expected to be launched on 2028. Just as an example, I think Gaia took 20 years between the presentation and the launch. Solar Orbiter around 22. And if things go well, for Ariel is 15 years. So basically, you can do your degree, your master, your thesis, become a professor, and I don't know what more. Okay, so it's basically half of your life as a researcher, if you want to work from the beginning to the end. Of course, this is difficult to keep, and specifically for research, because you cannot stay so many years without publishing anything. So at some point, someone thought, okay, let's try to find a way to make this kind of research of satellites, but with a smaller time frame. And that's the idea of CubeSats. So instead of taking you decades, let's try to do it in years, okay? And for example, these are CubeSats made inside the ICC, the Institute of Estudios Espacials de Catalunya. This is the 3K2. This is the FSSCAT, and this is the Anchaneta. Probably you know it because it's the last that we have had from the Generalitat. Okay, and all these different satellites, well, the first two are for Earth observation, and the third one is for communications. So these are examples that have took basically 5 years to be developed, and in this case, the time frame was just 2 years to be developed, and 2 years that it will be living and going around the Earth. So this means that instead of 20 years, we move to 2, 3, 4 years. So I think we can do a thesis in this time frame. Just a little for history. The CubeSat was born in the 1999. Thanks to Jordi Puig, which is from here, from Catalonia, who was professor at California Polytechnic State University, and Bob Twiggs from the Stanford University. And the idea was to be able to do Sputniks, but with present technology. So instead of having a big ball that is 1 meter more or less, made of steel, we make a small satellite that is 10 by 10 by 10, so 1 liter, that you can have in the palm of your hand, and that can do exactly the same as a Sputnik and many things more. Okay. So basically, this is the mechanical interface of this device. So you can see that this is just the definition, nothing more, nothing less. This is a CubeSat. Then you can put inside whatever you want. Okay. So it's totally free what you put inside. You can also have bigger ones, so 1.5, 2, 3 units, 6 units. This is 8, 12, and 16. So you have plenty of different sizes, and all of them are CubeSats. And the big advantage is that now you can go to a website. Instead of being called Amazon, it's called CubeSat Shop. And you can go there and buy the things you need to make satellite. Okay, of course, this is not so easy, and as we know, when we buy things for a computer, PC, always we do that this thing as plug and pray that it works. So with CubeSats, it's something similar. We have to tweak things, but at least we have some components that we can shop, so it's easier to design them. Okay? But as I said here, they are still satellites. So you still need some components. This is a description of a satellite, a graphical one. So you can see here that we need the payload. So if we are going to make astronomical studies, for example, and we will need a telescope. So we have to add this payload. Also, we have to find the proper trajectory for this satellite. So we need to make these calculations. And we also can need, for example, some attitude and orbit control. But as we don't want to have too many mechanical systems, because always mechanisms have issues, we try to find trajectories that allow us to avoid these mechanisms. So let's say that we have to open our mind in the sense that we don't have telescope like on ground, so we cannot point wherever we want easily. So if we can just work in a scan mode, probably our lives will be easier and things will work better. Okay, we can also need some structure. We'll need for sure communications, because if not, we are not going to be able to get any information from them. Power, and as I said, control and orbit station keeping, for example, for the satellite. Okay. So inside the ICCUB, as member of the IEEC, is working on some projects presently in the mission for the Earth observation Catalan satellite. Okay, and we are developing this secondary payload that is basically an onboard data handler, so a device, a computer that is able to process very quickly data, for example, for compression. And we are using the compressor from Gaia inside, more or less, the Gaia 1, inside this onboard data handler to reduce the quantity of data that we have to download. Well, Jordi will present it better than myself. Okay, and you can see here all the work in the lab. So this image was taken just Friday, and we have to provide this device in 1 week or two to Open Cosmos, because it will be launched, if things go well, during summer. Okay, so we started this project, I think, 2 years ago, and presently we are just trying to launch it. So as you can see, the time frame is quite short compared to classical missions. So in this sense, what we have, CubeSats are a change of paradigm in the sense that we have to be imaginative and opportunistic. For example, you want to get information, for Earth observation, you need some radar, and you need some emitter for this radar. If you have to put an emitter inside the CubeSat, it will need a lot of power, and that doesn't work. So please, if you have another signal, for example, the one provided by the GPS satellites, you can use it, and it will help you. Other case, there are some people that are thinking to use the Ionosphere as a telescope for ultraviolet. So if you are using the Ionosphere, you can try to measure this signal with your satellite, and checking what happens with the GPS, you can then analyze the ultraviolet. So these are opportunistic solutions, because you have these signals available, you make use of them, and could be you get what you need. Of course, there is some risk, but everything has some risk, and if you try to do it from ground, this is impossible, for example, for the ultraviolet. Okay, so why not? Also, we have to search simple ways to do things. We are probably used to have plenty of things on ground, but there, if something is too complicated and we have to, and it fails, we cannot go up and solve it. So try to simplify things. As I said, minimize the use of mechanisms. We have good computers, so try to use software, try to use electronics, because the failure rate is smaller. And also you have the advantage that you can use latest technologies. Take into account that if we are talking of, for example, from Solar Orbiter, that I know better, the technology is from 15 years ago. When the mission finished, it will have lasted 10 years more, so it will be a technology from 25 years ago. So things have changed quite a lot. If not, look at your mobile phones. Okay, so if you are able to use the latest technology, you probably will be able to do things that when the mission was started was impossible. Okay. Another important thing, keep it simple, and sometimes some people are stupid. Okay, so this is the idea. Simplify things as much as possible. Things shall be good enough, not perfect. Okay. Also, things are more predictable. Okay, so it's easier to know what is going to happen. And of course, risks are easier to manage because you don't have to follow different paths. So, as this phrase says, and I like it a lot, they did not know it was impossible, so they did it. And these things happen. I always say the same. The only limit that you have are the laws of physics. So any other thing you can change. Laws of physics, of course, if you are able to change them, then you will win a Nobel Prize. But I'm not the one that is going to do that. So I will just try to tweak them, work around them, but any other aspect will be able to modify. We are able to modify it. So proposed missions. These are missions that we have been talking or proposed to ESA, for example. In this case, this is the down-dash debris detection CubeSat, and you will say, what is that? Well, as you know, we are having issues with debris on the space. So we have orbiting the Earth lots and lots of debris, and we are starting to have a problem with this pollution. Okay, so we have proposed to ESA the use of CubeSats to make in situ studies of these debris. Okay, and ESA has not said no, but has not said yes still. So we are there. Another mission is Trescagea. This is an Earth observation mission that will be the next payload, or we expect to be the next payload for the CubeSats of the Generalitat. Okay, and it will include cameras, an RF payload, and use GNSS signals, as I've said, to analyze the ground. So we can make some science using these global navigation satellite systems. And another one is the FOTSat, which the name is not very good in Catalan, but anyhow, it will be the first IEC astronomical mission. Okay, and the idea is to do something similar to what Gaia does, but in a more simple way. Okay, and have a photometric catalog of different stars. Okay, so we know what we want. We are trying to see if it is feasible or not. So if the technology allows that presently, we want to have multispectral camera using visible, of course, near infrared and near ultraviolet. And why near ultraviolet? Because we can see it from space we cannot see it from ground. Okay. However, we have to see if this is feasible or not. So we are making the studies presently, and if things go well and we get the funding, we expect to launch it in 2 years. Okay, and the ICCUB is quite involved in this mission. So, summing up, I will say that from my point of view, Smallsats are a very good opportunity for science missions. The only thing is that we have to change a little bit our mindset, but apart from that, we can do many things there as we do here. You just have to think what happens with mobile phones. We didn't thought at the beginning it was just wireless phones, and today we do everything but calling with a mobile phone. So this is exactly the same. These CubeSats will be able to do anything that we can do in a mobile phone, and more if you want. Okay. Also, the costs are very small, because we are talking from millions of euros. We are from hundreds of millions of euros, which is a classical mission, to less than $1 million. So I think it's more easier, and also half of this budget is just the salaries of the people that is working. So I mean, it's interesting. Of course, it's complementary to big missions, because there are things that physics doesn't allow. So you need a telescope, and if it has to have an aperture, it has to have an aperture. So you cannot change that. But you can use them as a complement to these big missions that take 20 years to be developed. Okay, also to make in-orbit demonstrations. As I commented, the Generalitat is preparing this new space strategy, and they have launched one satellite. Now we are going to launch another. So this means that we are going to have an ecosystem around us that will be able to launch these satellites. So probably it will be easier for us to develop them and put them in space. And that's all from my side. So thank you.
Thank you very much, Emma. We have time for questions.
What will be the lifetime of these satellites? For example, Anchaneta, when will die? What is foreseen to die the satellite?
Usually is 2 years. It mainly depends on the orbit. Okay, and Anchaneta was designed to last 2 years on space. If you can move it at higher orbits, then they can last 20 years. The main difficulty then is that you have to ensure that they go down to Earth in less than 25 years. So, but apart from that, you can do it. Okay. Sorry?
How do you make sure that they go down?
Okay, because in principle they will go down. That's for sure.
Russians shoot them.
The problem is when, and this is just analysis of orbit analysis. So they just have some simulations and they study if it's possible. Also, it will depend on the sun behavior and many other things. But you can make a more or less close study about when it's going to die, and they fail by months. So no, there's no problem.
The rest of the satellite arriving on the ground will be just nothing.
Nothing, just dust.
So there is no problem with where will.
No, but they are small, so yes, it becomes dust.
Yes, thank you. So about this small satellites program, what I was worried about, and I mentioned to Ignacio Rivers, is there is this effect called, I think, Kesler Syndrome or something. I don't remember the name. The scientists that around 1990 predicted that if you have junk in space in low Earth orbit, there is a chain reaction that once you have some objects destroyed, and because they collide and then they produce small pieces, then these small pieces can destroy more objects, and then quickly you get the chain reaction where all space around Earth and low Earth orbit is populated by this debris, and everything gets destroyed. So the thing I remember is that this is a chain reaction which doesn't warn you. As you put more junk, and all of a sudden, just non-linear effect, it jumps, and then you cannot put anything in low Earth orbit. So it looks like with these small satellites, it's a perfect way to make this chain reaction start. So all the business goes out in a few years. Then, is anybody writing a report on this thing about governments and worrying about this?
Yes, well, us, for example, are worried about this. This is the reason why we propose the constellation to study the debris. But yes, this is the Kesler, as you have mentioned, is the Kesler Syndrome. I think there was a movie where you can show, you can see it. It was Gravity. And the problem is, as you said, that you don't know when it's going to start, but when it starts, you cannot stop it. Okay? But in principle, the problem are not the CubeSat. The problem is that we have these big constellations that have thousands and thousands of satellites, and this is not controlled by us. So these satellites, in just 2 years, 3 at most, they will be they will be dust directly. So that's but the ones that are up there, which are the big constellations, these are going to stay there. If they don't have some method for re-entry, they can stay there hundreds of years. So this is the real big problem. And also, as they are launching satellites towards some missiles to some satellites. We have had one just before summer, I think.
Yeah.
So, and this is much worse than any of these CubeSats, but because these CubeSats can be followed with radars from ground, but the small debris that is around that is thrown from the satellites cannot be followed. So this becomes a real problem.
Okay. Let's move on. Let's thank Chema again.